Hey guys, good evening all of you.
Good evening, bro.
Hey,
Good
good
evening,
evening,
bro.
buddy. Hey, good evening.
Good evening, sir.
Good evening, Tali. Okay. So guys, in the last classes we were discussing about, right? So we have done with, I think so, all the concept of the state span tree, right? Yeah, I think so. Yeah, no. So we have done with the span tree protocol states, right? And we have also seen that what is a spanning tree, what is loop, and what are the types of loop, right? And we have seen how a spanning tree make loop-free path, loop-free topology, not path. And we have seen the RP election, DP election, and we have seen the blocking election, as we have seen the root bridge election as well as, right? Anything else? I think so, not yet. We have seen the manipulation of the cost, and we have seen the port ID concept as well as, right? The 16-bit of number, the 8-bit is going to represent the port priority, and 8-bit is going to represent the interface number. The port priority you can define in the range of 64-bit as well as it's not 64-bit, 64 increment number of 64 and the 16 and as well as, right? It could be 32. It's totally depend on the switches isoism, right? Now, so if you remember that the first day of the class, I told you that this we have a spanning tree topology that is introduced in 1984, right? And we have a flavor of that one. So we have a flavor CST protocol, we have a PVST protocol, we have a RSTP protocol, and we have MSTP, something like this, right? So I told you that first you need to understand the concept of the CST, then you have to go for the PVST, then you have to go for the RSTP, and then you have to go for the MSTP. So likewise, right, you have to follow the path of baby step, right? So what is the issue with the CST protocol? And why we are using the PVST was the reason. I'll tell you. In a CST, what happened? If I talk about the CST protocol, CST means what? Common Spanning Tree Protocol. Right? It means that for every VLAN, we have a single spanning tree logical replacement. It means that you will have a one root bridge for each VLAN. And as we know that this is for the bracket one, each VLAN has separate broadcast domain, right? Each VLAN has a separate broadcast domain. So normally what happened in a CST protocol, we have a common for every VLAN, right? It doesn't matter how many VLANs you have. You have a 1 to 100 VLANs, 1 to thousands of the VLAN, 1 to 3,000 of the VLAN. You will have a only one logical topology. You will have a only one root bridge. Like one person is going to manage, right? In a simple language, I can see that in the CST behavior. In CST, if you compare with the real life example, one person manage 1,000 people. Right? That was the CST. Like for example, if you see this diagram, this is the switch one, switch two, and switch three. Right? And a normal topology we have this is the DV port, right? Above this is the DP, this is the RP, and this is the RP, and this is the DP, and this is the blocking, right? In this case, what happened? Doesn't matter how many VLANs. For example, you have some user over there. Take example. We have a VLAN number 10. This guy. Some user for the VLAN number 10 on a switch one, right? VLAN number 10. Some user is present on VLAN number 20, and some user is present on VLAN number 30. Same thing, we have three VLANs over there. Switch 1 as well as, and switch 3 as well as. We have three VLANs. Do you know in this case what happened? For every VLAN, VLAN number 10, 20, and 30, 10, 20, and 30, and 10, 20, 30, who is the root bridge? This is the guy that is the root bridge. So what will be the logical topology for this person? Someone mic is on, please. The logical topology for this person will be like this, right? Switch 1, switch 2, and switch 3. So this is my 1 minute. So this is the switch 1, switch 2, and so this is my logical topology. For every VLAN. So in that case, what happened? Try to understand, if you talk about this topology per CST protocol, we are not going to utilize this particular segment. We are not utilizing. It's totally wasted in the case of CST, because you will have only one root bridge, right? For entire VLAN, right? The entire VLAN we have 124094. For entire VLAN, you will have only one root bridge. For entire VLAN, we can say that you will have only one logical topology. Entire VLAN. So if I talk about this case, right? This particular case, in this particular case, what happened? Take example, this is the 10 Mbps link. Can I utilize this 10 Mbps link over there? No. We are making a load on which particular link? All this VLAN number 10, 20, 30, whatever the user are sitting over there, all this guy will send the traffic through the this one. All this guy. Can I manipulate this thing? Yeah, of course you can manipulate, but I still take example. If I'm going to make this guy as a blocking, and this guy is now forwarding state. If this guy is a blocking and this guy is now forwarding state after doing some manipulation in the port ID and cost, what happened after that? Can we utilize this particularly now? No. So at the end of the day, what we can see that the CST protocol, right? This guy is, in the term of scalability, is not good. This is not so flexible, right? Yeah, of course, this requires a very less amount of resources, right? Because you will have only one root bridge for the entire VLAN. That requires a very less amount of resources. But again, what happened? It's totally wastage of the resources on this particular segment, right? We cannot do the load balancing in CST. We cannot do the load balancing in CST protocol. Not possible. If I talk about the different example, so in this case, what happened? We have wastage of segment. Now, if I talk about this different example, switch one we have. Take example, we have a system. Switch 3 we have, and switch 4 we have. Switch 2, switch 3, and switch 4. All good. So we have this particular link over there. We have 0/0. We have 0/1. We have 0/0. We have 0/1. We have 0/0. We have 0/1. We have 0/0. And we have 0/1. Right? Take example. We have some user data sitting behind this guy, right? So we'll draw some user. that belongs to the VLAN number 10, right? And this guys belong to the VLAN number 20, right? Ten, 20. So I have this guy's a 10, this is 20, this guy's a 10, and this is 20, right? So this person is for the VLAN number 10. This guy is also VLAN number 10. This guy's a VLAN number 20. This guy's a VLAN number 20. Now try to understand in this case what happened. We have two VLANs on our switch 1, switch 2, and switch 3, right? I'm still talking about the CST protocol. I'll just let you know the problems of the CST, then you will understand the concept of QST protocol. What do you think? How many root bridge you will have? Any one of them will become the root bridge? Either switch 1, switch 2, switch 3, switch 4. I'm taking example. Switch 2 is a root bridge. Take example, right? It's a root bridge. So if this guy is a root bridge, what happened? This interface will become the DP, right? If I'm not wrong. This interface will be DP. This interface will be RP. This interface will be RP, right? Then this interface will be DP. This interface will be RP. This interface will be, of course, if the cost will be tie, so this interface will be going the blocking, and this interface DP, right? Is it? What do you think over there? This complete segment, can I use this complete segment over there? Okay, 1 minute. Can I use this segment, complete segment over there? No. So whatever the user out there, VLAN number 10, if they wants to communicate with the VLAN number 10, my traffic will follow like this, right? And if the VLAN number 20 wants to communicate with the VLAN number 20, my traffic will follow like this. So the entire segment, right, I'm not going to use. So it's a totally wastage of the switch 3 as well as this segment and this segment. In the case of CST protocol, because CST is saying, hey, it doesn't matter how many VLANs you have, you will have only one root bridge. You will have only one logical topology for every VLAN. You will have only one logical topology for every VLAN. And this is right. This is not a good solution nowadays. Not now, it's 90s, the time of 90s. It was not a good solution. So they came with the mechanism called as a PVST protocol. PVST is a name standard for product VLAN spanning tree. And what this guy allow you? It allow you to have, one separate logical topology for every VLAN. It means that you will have one root bridge for each VLAN. So I can do the load balancing. I can utilize all the network resources, like all the segment, all the switches. Of course, this will require, as compared to the CST protocol, PVST require the huge amount of CPU process, right? Right. That's of course, right. As compared to CST previously require huge amount of CPU resources. The reason is that because you will have a separate topology for each VLAN, separate root bridge for each VLAN. So of course that will require the huge amount of process, right? But again, what happened? What's the benefit we are getting over there? The benefit we have this guy. I can do the load balancing that is not possible in the case of CST. How the things will happen? Have a look. Take example. I'll just draw the one simple topology to in front of you. Switch 1, switch 2, switch 3. Right? And now the difference over there. Switch 1, switch 2, and switch 3. Right? We have a VLAN number 10, 20, 30. 20, 30. 10, 20, 30. 10, 20, 30. If I run the CST protocol over there, what happened? If I run the CST protocol, your logical topology will look like this, right? Your logical topology will look like this. This interface, of course, in the blocking state. In the case of CST, right? You will have only one logical topology in a CST protocol. But if I talk about the PVST, in PVST, what I can do right now, I'm going to make, right? Hey, listen. Okay, let me go on downside. And in the case of PVST, what happened? I will make this guy, hey, you are the root bridge for the VLAN number 10. So of course, if you are the root bridge for the VLAN number 10, this link will be blocked. Understand this concept is very important. If I talk about the case of, I'm going to make now because we do have ability, right? We can determine because in the previous case, what happened? For each VLAN, we have a separate root bridge. We can make it. So I can make this guy as a for VLAN number 20. You are the root bridge. So which link will be blocked? This link. And for the VLAN number 30, I'm going to be, hey, you are the root bridge. Which link will be blocked now? This link. So can you see that at the end of the day, what happened? I can utilize all the resources. In the case of PVC, in the CST, what happened? You will have a 3 VLANs, but how many logical topology? Single one, right? Single one, CST. In the case of PVST, what happened? For the VLAN number 10, we have a separate logical topology. For the VLAN number 20, we have a separate logical topology. And for the VLAN number 30, we have a separate logical topology. We can, at the end of the day, utilize all the network segment, all the segment, all the link we can utilize in the case of PVST. That's called as a for VLAN spanning tree. The election process, everything, it is same that we have discussed. And from the first starting day to the till this point, what we have discussed regarding to the PVST protocol, because you cannot enable the CST. CST is totally legacy. So this beauty you can achieve by implementing the PVST protocol in your network. At the same time, in that case, what I can do in this topology, I'm going to make this guy, hey, you are the root bridge for which person? Now you are the root bridge for the VLAN number 10. And you are the root bridge for the VLAN number 20. Now see what happened. My VLAN number 20 person will send the traffic through this link, and VLAN number 10 will send the traffic through this one. We can achieve the load balancing. Right? I just need to manipulate the something over there, right? And after that, I can achieve the load balancing. This is how the PVST works, guys. This is the best example. Now, if you have a look, the configuration part is very easy. Yeah. 960 and switch 1, switch 2, switch 3, switch 4. All good. Some PC1, PC number 2, PC number 3, PC number 4, right? Cables. Like this, like this, like this, like this, like this, like this, and here to here. I'm going to make this guy as a PC number 1. So I'll just configure the 101 IP addressing. This person belongs to the VLAN number 1. Come on. This should be PC number 2. This should be IP address will be different VLAN. So 2.2.201. And this guy's a 102. Same VLAN. This guy's a 2.2.2. And so this is the 101. This is the 102. This is the 2.1. And this is 2.2. This is the guys the VLAN number 10. This is the guys the VLAN number 10. This is the guys the VLAN number 20. This is the guys the VLAN number 20. Normally, what happens if you see by default, this guy is running with the PVST protocol. Normally, in this switches, what happened by default is running with the PVST protocol. Again, thing is that depend on the platform, some guys is running with the RSTP protocol. If you talk about the newer Cisco IO solution, they are running with RSTP. If I talk about the older one, they are running with the PVST. So if somebody will ask, hey, which protocol by default you know? It's depend. Right? If I talk about this guy is running with the by default PVST. Or in this case, what happened? Did I do any manipulation over there? No. Have I created any VLANs? No. So let's do the VLAN configuration. So this interface 0/1 we have, and this is the interface we have a 0/2, right? So I'll start my notepad. Okay, not this one. As for switch 1, and I have something called interface 0/1. Switch port access VLAN number 10. Switch 2, we need to create the VLAN. Right? Our interface 0/1, switch port mode trunk. I need to create the trunk and switch to switch port mode trunk. Switch 3 now. Same configuration of switch 3 as last, nothing we have to do, change. And switch 4. Switch 4, we have this interface is 0/3, and this interface we have 0/4. Copy. And no need to create the VLAN out there, automatically they will create, right? They don't have any VLANs. So first they will create it and then assign the interface into the particular VLAN. All good, right? So let's copy configuration from here and switch 1. Then switch 4 now as well as. All done. Switch 3 and switch 2 have the same configuration. So let me open those switches and define the host name first of all, right? So we can easily identify what switch we are present, right? Switch 2 and copy. Oh. Yeah, it's correct, right? And we have this as well. The reason is creating the each VLAN on every switches. We don't have a BTP right now. That's why I'm creating. If you have BTP, you don't need to put this VLAN on every switches. And all done. Wait for some time. Previously, there was a one blocking code over there, right? Wait for some time because it will take the 30-second, right? Listening, learning state. Still, this guy's a blocking state right now. Why the reason is happening? Because one of the switches is switch 3, maybe if you see on the switch 3, do so spanning tree, so spanning tree protocol, and this one switch 3, right? Let me define the host name. Can you see that? Switch 3. For the VLAN number 1, right? He's saying that, hey, I'm the root for the VLAN number 1. If I talk about the VLAN number 20, sorry, 10, I'm the root. So he's electing the root bridge for every VLAN. And for the VLAN number 20, he's still saying that, hey, I'm the root. So that's why right now, this is the guy, right? He's the RB for VLAN number 1. He's the RB for the VLAN number 10. And he's the RB for the VLAN number 20. So all my traffic, right, doesn't matter if this VLAN number 10 person wants to communicate with the VLAN number 10, all my traffic will follow like this. And all my traffic will follow like this for the VLAN number 20 as well. Because this is the blocking, right? The complete segment I'm not going to use. The complete entire segment, not the complete entire segment I'm not going to use. From one location to a different location is totally wastage of the resource switches as well as. So what we can and what we approach we can follow over there to resolve this one. I'll tell this person, hey, listen, you will be a root bridge. Now pay attention, guys. I'll say, hey, you are the root bridge for which person? For the VLAN number 10. And you are the root bridge for the which person? For the VLAN number 20. How do I do that? By default, what's the priority is happening? 32768. And then we have a VLAN number. That's this guy 3276 7778, right? Normally, this is how the system ID extension, right? This is the guy. That is uniquely identify. Okay, this BPD is belong to the VLAN number 10. So priority is by default 32768. And then after what happened? The spanning tree protocol added the VLAN number into the priority, and totally it will become the 32778. For example, for this person as well as 32768 will be default priority, and the VLAN number 20 will be what? 327 what we call 788, right? If you have a look, sys 3 and for the VLAN number 20, it's going to be added, right? Before priority, and I'm going to add the system ID extension. And same thing over there. Ten for the villa number 10, right? Of course, I'm going to add the villa number for the villa number 1. So what I'm telling this person, hey, you are the root bridge for the villa number 10. What I'm going to do, I need to reduce the priority because lower priority is more preferred, right? Lower priority is more preferred, or either you can use the word, hey, you will be a primary. Two things are there, guys. Either I can decrease the priority for this particular person, right? And decrease the priority for this particular person on the switch 3 and switch 2 on this person. Or either I can make it this guy, hey, you are the primary for the villa number 10 and you are the primary for the villa number 20. And that will be awesome. It's up to you, right? Let's take example. What I can call over there. This two, I will say that, hey, listen, Hispanic villa number 10, I can make the priority will be 0, right? Sorry, not 0. Make the increment of any order of this range. The reason is to make this range. Why? Because let me do one thing. Let me copy this guy and I'll explain you in the paint file. Now the thing is that you are always going to increment the priority will be order of 4096. What is the size of Bridge ID, guys? Remember, recall the same thing. 8 byte. In 8 byte, the 6 byte is going to represent as the MAC address, so I'm not going to deal with this person. Leave it. 2 byte is going to represent the Bridge priority. In this 2 byte, what happened? We have a 16 bit, right? 16 bit means what? The 12 bit is going to represent the VLAN ID, something called as a system ID extension, right? This guy number, guys, have a look. This number I'm talking, okay. Come on, where are you? This ID, the 12 bit. Why 12 bit? Because the size of VLAN is 12 bit, right? Why 12 bit? Because the size of VLAN is 12 bit. We have a range of the VLAN from 1 to 4096, right? Sorry, 4094, the 12 bit. The rest 4 bit is what? Priority. 4 bit, how many values we can get over there? 2 to the power 4, 16 values, right? 16 values you will get. So why this increment is happening in the 4096? Just because of this person. And 4 bit priority is this guy. Count over there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. You cannot define any other value, right? I put the 323, it will form the mass. Hey, British priority must be increment in the order of 4096, and you have to use this range. And what's the default one? Reason, mid value. So either I can tell this person, hey, listen, what I'm trying to say, listen, you are here, like, you know, I'll say that, hey, for the VLAN number 10, I'm going to decrease the priority. So you will become the root bridge, right? Of course. So either you can use this command. Sys2 should be I'll make this guy a 0 priority, that's fine. And sys3 will be Done. Two options are there. Have a look. Done. Answer 3. Do I need to modify this guy? No need to modify because this guy has a lower MAC address, but still, just for the task, done. So now, if you have a look, the sys2 now, can you see that? Now the sys2, right? This is the guy sys2 we have. It's the root bridge. But am I the root bridge of the VLAN number 20? Of course not. I'm not a root bridge. Same thing if you go to the sys3, sys3 will be a root bridge for which person? For the VLAN number 1, that's a default one because of the lower MAC address. I'm not a root bridge for the VLAN number 10, of course, right? VLAN number 10, this guy is a root VLAN. Who is this guy? Sys2. And the sys3 is still will be a VLAN number 20 root bridge. Reason because I define this guy like this. So now, if you have a look over there, guys, you can see the beauty. I don't have any blocking. Can you see that any blocking ports over there? I can do the load balancing. Have a look. Let me check our first connectivity over there. So I'll ping. Oh, come on. It's working. And for this guy as well as ping. Awesome. So we do have a utility. If you have a look now, here to here, my VLAN number 10. Who is the root bridge for the VLAN number 10? This guy, right? So my all traffic will follow which path? The top one. My return traffic also follow the same path. All done. If I talk about the VLAN number 20 now, this guy to this guy, I need to follow the down path, right? Return traffic. So now we do have a load balancing because the root bridge, this is the primary and this is the secondary one. So you just need to manually define those command. So as compared to the CST, now we have a two root bridge, right? For which each VLAN we can make it. Awesome, right? This is the one way that you can achieve the same, like, the primary, what we call the load balancing. And here we need to change the priority. So if some requirement is coming, hey, you need to make this guy as a root bridge, you need to make this guy as a root bridge. So you can do like this, right? I'm utilizing the complete entire the network resources, right? The cables, switches, and everything. If I talk about the another way, we can define the command spanning tree, VLAN number root primary, and I can tell this person, hey, this is the switch 2 now. Switch 2 should be root reach for the VLAN number 10. At the same time, you do have an ability, right? I can define, hey, listen, you are the primary, but at the same time, for the VLAN number 2, you will be a secondary. For the switch 3 now, it should be not 20, so we will. So we have a two another ways we. What make a difference between this guy and this guy? If I use the word primary, keyword, right, on the switch 2, what it will do, it will decrement the priority from the default to 4096. If you have a look, I'm just going to switch 2 now, and let me remove the previous command that I used to make this guy as a spanning tree VLAN number 10. Hey, you are the root primary, and spanning tree VLAN number 20, you are the root secondary, right? So now show a spanning tree protocol. What this guy is doing, right? Calculator. Sorry, I said that 4096 not. It should be 8196. 3276. 8 minus 8196. 4096, something like that. And equal of 4094. 94. वैसे निकाल लेता हूँ. I am not able to recap the exact value. 32768 minus 24,500. I'm really sorry. 76, right? Of course, the VLAN number 10 will be added, right? That's right. 8192, exactly. If you're going to use the word primary keyword, right? Note, if you use primary keyword, so it will reduce, not switch, spanning tree protocol will reduce, or we can say that decrement the priority from 32768 to, or we can say not decrement, minus the default priority minus 8192. And if I use the word secondary over there, then it will use the 4096. So if you have a look for the VLAN number 20 now, 692. So let's open the calculator and 32768 minus 28,672, right? It's 4096. Same value. So this make a difference, right? So it's up to you guys. You can use any one of them. But again, this is a more recommendation to use it. This is more secure than this one. And here we have done with the PVST load balance. This is how the PVST is working as. Anyone has a questions, you can ask me.
No, if we use primary, we need to configure secondary also.
It's not requirement. I saw that.
Okay. So just we can configure with primary command also.
Yeah, I just show you the commands are available.
Okay, fine.
You can go on the switch 2 3 and let's do one thing now. I'll prove it. So hey, listen, you are the not this command I'm going to use. That's this 90 VLAN number 20, you are the root primary. I'm not going to define you are the secondary for the VLAN number 10, right? So VLAN number 20, this will be a root and the priority has declared. We are defining anything over there. The secondary for the VLAN number 10. No. Questions, guys? Anyone other questions? Anyone? No?
So in both cases, priority will be changed, right? Either it is we use priority or primary.
Priority plays the important role, right?
Oh, so priority is the game changer there.
Yep, here's the game changer, right?
Oh, fine.
No, if it is secondary, it should increase the priority, right?
If it is secondary, lower priority is always preferred, right? So of course the primary will be decrement more than the secondary, right? Because lower is more preferred.
Okay.
Hello.
Yeah.
You have used priority 0 in the first comments. So suppose if you want VLAN 20 to be primary in that case.
Sorry, which VLAN?
You have used priority 0, right? Priority 0. Suppose if you want VLAN 20 to be priority, I mean less priority than that.
Yeah, there's no less priority below the 0. There's no less priority below the 0. 0 is the last one. Listen, are you getting the point? Like what I'm trying to, if I'm not able to understand your question, I don't know what you're asking. Like you're asking, like, can we do the priority below the 0?
Not exactly. Like we can. So now the primary is on switch 2 is VLAN 10. Can we make VLAN 20?
On the same switches, you are saying that?
Yeah, on the same switch.
Of course, you can do that. That's not a big deal. You can do that, but again, that's
what the priority you will use then.
You can use the 0 as well as you can use any of the priority. That's not a big deal. It's up to you. But again, that will not give you the desired result that you want, right? Load balancing.
Oh yeah. I got it.
Any other questions, anyone? Okay. What can I learn that this man? Hey guys, so leave it for the today till this point, because we'll do the topology chain notification, right? The TCN mechanism, right? We'll do it tomorrow, right? And this Friday we have a class. Same time, 8 p.m. Good.
Okay.
Anyway, yeah. So to Friday we have a class 8 p.m. TCN will be happen tomorrow. And another thing is that I already mentioned that we have a ISS protocol class. So who has done with the routing part, you can attend the Saturday, Sunday ISS protocol. Who has done the routing part? Not done, leave it.
Timing law?
Same time, 8 p.m.
For ISS also, right?
Yeah, ISS protocol. So if you understand the ISS protocol, you're like, SD access part, these are, see again, these are not a part of the CCNP and not even the CCI part. Okay, just I'm teaching you, like, some people has requested me for the classes, that's why. So only for 3% I'm teaching this class person. So the 3 people has requested, they are from the corporate. So I said, okay, let me add the more people over there. So you can attend the ISS program as well. But again, this is the future, right? The ISS protocol. Like, the all the future things are coming, like, if you go for the data center part, the VXLAN, LIPS protocol, all the SDX, they are coming with the ISS. Hello, can I have a, yeah, of course, Salman, tell me what happened.
Law, I have a questions about IPsec.
Please ask me.